Tonasco is a precision machining company specializing in very small and complex precision components for high-tech sectors such as semicon, optical, medical, and diagnostic sectors. Please welcome, ladies and gentlemen, Ms. Lin Sheau-Wei.
Thank you. Thank you for having us, Tonasco, to share our digital twin stories. And as the group MD, I will share more from the business and the dollars and cents perspective of why Tonasco choose to invest in digital twin technology in the first place. Yep. This is a picture of our plant, our second factory, based in Bukit Jelutong in Malaysia. And here we actually just finished our renovation last year. So we have two factories, and we've just moved most of our machines in. You can see that there is CNC machines, different kinds at the back, and the robots, all kinds of IoT enabled. And this is a bit of image of the Tonasco Smart Factory. So a little bit about who we are. We started since 2006. So we've been in the business for 16, 17 years. And what we specialize in is we make very high precision, very complex, very small machine components, and also sub-modules. And we do that in really high mix, very low volume. I'm talking about single piece, one piece sometimes. So what it means is that in 1 month, we used to have about 2,000 to 3,000 different components that we make. And many of them, we make it for the first time and for the last time. So it never repeats. So if you do a quick calculation, 1 month, 2,000 to 3,000, 1 year, you get the math. So with so many parts, what we need to do is we need to be very, very organized. And we need to have very good system. Going back a little bit of history, when we started, we do a lot of, we export 100%, by the way. So most of our customers are in Europe and Japan. We are starting to develop our market there, but mostly in Europe. So over there, we were very active in automotive industry and all. But as we see the transition of the industry and a few other factors, we start to court more and more high-tech customers. And also because we are getting better at what we are doing. So we started to see that the kind of job inquiries that we get are getting more and more complex. So what it means is that we need to be even better with what we do, but at the same time, the equipments, the machines that we use needs to be better too. So we start to look into something like 5-axis machinery and other technologies. At the same time, as all of you know, talent shortage is a huge headache. No matter which industry you are, having talent is always a difficult challenge, and especially for machining industry. In the past, we used to have expats from India, Philippines, as our machinists. And as it becomes more and more difficult because of policy changes and all, it becomes more difficult for, it gets more difficult for us to get the talent that we need. So now you have a job that is more difficult, more complex. At the same time, the very experienced machinists that you need to run and to produce those kind of very complex components are getting more difficult to find, and they take very long time to train to really become the master level. So along with all the exposures that we have when we visit our customers in Europe and all, 10 years back, you start to hear a lot of Industry 4.0 revolution. At that time, many people still not very sure, is it a myth, is it ever gonna happen? But as the technology advanced, you can see that things are moving very fast, and now even in Malaysia, all our government is talking about all the factory needs to go Industry 4, digital transformation and so on. So in 2017, we decided that, okay, we need to automate, we need to robotize, and we really need to embrace Industry 4, meaning we need to expand with a smart factory, not just buying more of the same kind of machines. So a real strategy change over there. A lot of very complex technologies that we needed to learn, embrace, understand, and incorporate into our operation. So we work with our technology partners for 2-3 years, and then in 2020, we launched our first phase of our smart factory concept. Okay, thanks. Then you see, all right, then you bought robots, you have more cool machines, a lot of 5-axis machines, you have your IoT-enabled tool management system, yada, yada, yada. So then, fine, you have a smart factory already. But why do you still need to look into a digital twin? When we decided to buy the 5-axis machine, so just a bit of comparison, maybe some of our friends in a similar sector has an idea. A normal 3-axis machine, that is used to mill, cut the metal parts and all, they cost about, in the past, about 300,000–400,000 ringgit, one. A 5-axis machine costs around, the slightly smaller one, maybe 1.5 million ringgit, to about 3 million ringgit. And that is not even the most expensive one, just the ones that we find suitable for our small parts. So you can see that the value of a more expensive machine means that if anything goes wrong with the machine, it costs you more in terms of damages, it costs more chaos at the shop floor, and it's also more painful. Yep. So very simply put, we invested in digital machine because we saw that there will be a higher risk with a more complex 5-axis machine that has 5 axes moving together at a high speed and more powerful at the same time. So with this simple reason, we started to look into digital twin together with our experts. So where does the digital twin sit in our operation? Now, to know that, first, let me introduce very briefly about the general operation flow of Tonasco Smart Factory. When we get a job order from the client, we have a lot of details, delivery date, everything, material, etc. So we input it in an ERP system. And with that, we do our job planning. And after that, it goes to the programming department, where our CAM programmer will basically create a program that will eventually tell the entire production shop floor what needs to be done. They decide, they put the material information in, they decide what tool to use, where to cut, and how deep or how fast. So all based on the 3D drawing that we receive from our clients. And then after that, that information channel into the production. So here you can see in the tool department, based on the program, they prepare the tool. Which part for what tool, they set it, they measure it. And at the same time, the job management system also need to decide which machine needs to do what kind of product. And then it goes into the CNC milling machine. And if everything goes well, everything is decided correctly, by our very important team in the programming department. Then the product comes out, accurate, all in spec, nice quality, goes through the quality control, everyone happy. Remember, we are in high mix, low volume. So the amount of programming that we do in our organization is a lot more. They are human. We make mistakes. So what happens when there is mistake? If there is a mistake, if you have a very, very experienced machinist standing in front of the machine, they constantly will check, is the machine vibrating too much? Is there some weird sound? Is the movement not a bit off? Yeah. Or sometimes in the past, we have incidents that the pocket is, what we call the pocket, that means there's a slot that is on the other side, sometimes produced in a mirror image. That can happen, huh? Because of communication error and all, or a missing hole. So when that happens, the guys at the machining will need to say, hey, wait a minute, something is not right. He will stop the machine, and then he has to go and communicate with the programmer. And the programmer needs to go through, oh, where did I go wrong? And then double check the NC code. So you can imagine whenever there is an error, what kind of delay is possible, and the rejection, basically, cost and stress. Here is where the digital twin saves the day. So in the old days, the machinists are the bodyguard, are the safeguard of making sure that the machine doesn't crash and everything goes well. But with the digital twin, what we do is we run a simulation. We run a simulation of and making an automatic comparison with the 3D file that we receive from our client. So later I will share with you exactly how it works. What it means is that instead of waiting for things to go wrong at the production floor, we try to catch it in the office at the programming area. So if the digital twin simulation runs and identify that there are some programming errors, very quickly it goes back to the programmer, where he actually is the same guy that is running the program while he's programming another part. So he's happily having it at the background, depends on which version of the software, while he is actually working on another program. So he will then make sure everything checks out before it goes into the production floor. So that means everyone can have a peace of mind. You solve and troubleshoot everything at the programming department. That's the value. And we can make sure that our machine, very expensive machine, doesn't crash. What a digital twin in a machining setting looks like. So it looks exactly like your real machine. So this is basically the simulation. You can see the movement, the behavior, cutting. It should look the same. And what is happening is that after the simulation program is finished, the machine automatically detects where the problems are. If everything is correct in spec, then it is green color. If there is what we call overcut or undercut means you are cutting less material than you should be cutting, then it will highlight in blue. If overcut, collision risk, you can see here, it shows you that these are the process errors. And then you can very easy for the programmer to see, oh, this is the surface that has problem. But of course, sometimes because we have other processes, like for example, this one, we on purpose leave extra material because we need to make it into another step. But that is also a very good confirmation. If this surface is green, that means something is wrong. You need to adjust your program. So what you can see is that you have a very visual, very assuring confirmation with a digital twin simulation. So maybe some of you now are convinced, this digital twin seems like a good investment. Let's buy it. Give me a catalog. I want to choose the digital twin that goes together with that machine. I'm going to buy this machine, D200, from our partner, Makino. And here, another machine. Okay, then I'll buy this plus this. How many of you think that it's not so simple? Majority of you will think that something is not right here. It cannot be so easy. Otherwise, everyone will have a digital twin already. How we build it is that we need to look into a few important components. Thinking that this is a digital twin, that means this digital machine lives in a digital world. So that means all the information that this digital machine needs to have needs to be in the digital format. So there are a few key components. First, we need to have the machine 3D model and specification. That one you can get from your vendor. So you go to this machine vendor A or machine vendor B, they will have the file. So, okay, based on this, you build the digital twin. And at the same time, because inside the machine, you can see that we need to clamp the material. We need to hold the material. And then also we need to have tools. So all those information need to be digitized. So we spend quite a lot of time to digitize this, but beforehand, we need to standardize. It's not like, okay, today in your factory, you have 10 different types of clamp. You will just digitize the 10 different types of clamp. There's a risk there, because if your programmer there programmed to use clamp A and your factory, somehow they get confused, they use clamp B, you will still get a crash, because your simulation was not simulating based on clamp B. It's simulated based on clamp A. So what it means is that when we want to digitize something, you also need to have a very good understanding of how the operation is going to be like after you digitize all your processes. So here, we spend quite a lot of time to standardize what kind of clamping system we want to use. We get a digital file from our vendor as well, and that becomes another building block for our digital twin. The last one. This one, actually, if you look at this, this is like a mini digital twin. It's showing the digital model of my tool holder. So for the tooling, we spend a really long time. We have 2,000 tools, almost 2,000 tools, to record, to sometimes, even though we have some nominal file from our vendors, but there are certain things we still need to key in manually. So a lot of people think that digitization is just, okay, I just get everything in digital, but they forget a lot of manual work goes into digitizing. So if we get our expectation right, then we get less frustrated when we are implementing it. So after getting all these building blocks, we need to verify. So we send this digital twin to our partner, and at that time, our machine is not here yet. So we run and verify the machine kinematics. Is it really behaving exactly the same as what we saw as the new digital twin that we just designed? Is everything running correctly or not? Again, digital world is still different from the actual world. No matter how much you try to simulate, there is always some variables. So having done all that, now we have our digital twin. I have all the ingredients and maybe some license, depending on which one that you invest in. When we first started, we invested in a really expensive one. Cost us about 600,000 ringgit. Yeah. But the other version, when we partner with another CAM software provider, it costs only about 10,000-20,000 Sing dollar to set it up. And then your annual license is 10,000 Sing dollar, something like that. Still cheaper than a programmer's salary, annual salary. So think about that. So here, we started in sort of late 2018. And we built all the building blocks over here. And then we only managed to actually incorporate it in our operation, Q3 2020. Took us 2 years. That is already a very good timeline. Yeah. So, as of this juncture, you can see that we need a lot of research, we need partnership, and we needed to, because basically we needed to do a lot of work to build the first one. Then the second one comes a lot easier because you already have the experience. Majority of the building block is already there. And if you buy another new machine, you repeat the process. Here you can see now we use our digital twin at all our programmers' desktop. Nobody want to skip the digital twin simulation. And I'll tell you why. Because I asked them to record a video to tell you themselves what they feel about this digital twin.
As a programmer, the advantages of having a digital twin to simulate our programs is that we are able to release a 100% error-free program. It also saves time for us to check the programs before releasing, and also time to make changes if there are any errors. And finally, it makes programming easier as we are able to visualize how we plan to make a part inside the machine.
With digital twin, it gives a sense of security where I feel very confident to release my program when it checks that it's going to be accident-free, especially when it comes to 5-axis machining.
Watching of programming simulation before machining is really a good practice because it will increase our confidence level to operate our machine, and also in terms of accident and rejection, the hyper simulation is very important role. So especially for the trainees, new machinists, they have no clue what they are running inside the machine. So at least they can see like a movie before they're going to start our production.
Simulation is important because I am confident when running machine. I believe machine won't crash. And at the same time, I am save the time from checking and see. Also, we can reduce or minimize the rejection.
Okay. So, no, what I say, they say. Because I think sometimes it's very important to go back down to the ground floor to ask the people that are actually using this technology on a day-to-day basis, do they feel that there is value? So, and as you can hear from them, everyone really likes that this gives them assurance. So that was the shop floor value. How about the business value? What is the value for investing in the time, the hours, the tears and the sweat and the money into building your own digital twin? So first of all, as you can already imagine, as I mentioned, is a major risk reduction, is a great safety net for us, especially when we continuously invest in a more sophisticated, more complicated to operate high-tech machines. And the other one is that because of that, we are able to get machines that can do more. So that, in a sense, enhance our overall company capabilities. And not to mention, because you can do a lot of quality checking, prevent those kind of very obvious error happening, then it definitely impacts on your quality performance. And last but not least, it definitely resolves talent crisis. For a very simple example, nobody wants to do night shift anymore. I'm not sure about all your manufacturing staff. Night shift is always a headache to organize. And yeah, I see some head nodding. So with automation, we solve quite a bit of this kind of problem. We can run the more higher batches job or the job that we have already verified in the daytime. And then for the 200 batch, we run one. Okay, everything checks out. The other 199, we run at night. You don't need so many people standing by to manage the machines anymore. And that solves a big problem. And also at the programming side, imagine whenever you have a lot of issues in the programming and keep coming back, the programmer is always fixing problem instead of just focusing on creating the CAM program. And that definitely also take up a lot of the manpower at the programming, and this definitely helps to resolve it. So when we implement new technology, sometimes it's not very easy to immediately tying it to return on investment. How much profit because I invest 600,000 in digital twin, therefore I get how many % up in my profit margin. It's not so simple to calculate. But what you can do is to use other parameters, other measurement indicators to check out that this benefit, at least in some of these aspects, which, logically speaking, should eventually lead to better financial performance. So, 2 years, a lot of work done. For sure, we make mistakes, of course. It is something new to us altogether. So, I asked my staff, what did they learn from this whole exercise implementing the new technology? And here is what they say. Next.
What are the things that you have learned from the implementation of the digital twin?
Okay, first of all, I learned that the top management should share their complete vision to all the key personals and the employees so that they are aligned with the goal that the top management have. So the whole implementation process will be much smoother where everybody is working towards the same goal. It's one of it.
Yeah, I agree. I also think that the end user should be included in the pre-implementation because they have a clearer idea of what they want and what they don't need in digital twin software.
Agree. Another thing what I realized from this activity is that we should set a realistic time frame where this digital twin and Industry 4.0 is a new thing. So it's a new venturing. There's always going to be hiccups where things don't always go as what we plan. They're always like something doesn't work. So we have to be much more realistic and we should allow that buffer for us so that we don't get frustrated along the journey of implementing this digital twin.
Yeah, and I feel like having a good relationship with your technological partners is also important, especially the ones which are developing with you in achieving the same Industry 4.0 goal. Yeah, so having a good relationship with your digital twin provider, so you can improve together.
Yes, true.
So now that you have already experienced implementing the digital twin, would you do it in the future again?
Yes, with the experience that we have done, I think we will do it again, which is going to be beneficial for us and the company itself. Yeah.
So, what's next? There are still a lot we can optimize with this digital twin integration into our operation. Like I said, not everything the digital twin can simulate. The temperature in my factory, the vibration of the machines. There are a few other things that the digital twin doesn't have information, like the real world. So there are room for optimization, and we are working with our partners to see how we can bring this further. And if you take a step back away from just looking at a CNC machine, you look at the whole factory. Like I hear from the previous speakers talk about digital factory and all. Why not? If I can look at the entire operation of mine simulated to real time, as realistic as possible, to know every component of my factory, which one is optimized, running smoothly, which one has issue that will trigger us to do that, and with the machine learning technology, with data analytics and all, the list go on. So it's a mammoth elephant to eat. So what we need to do is that to still stay very, very focused in our course of going forward with automation, with the whole Industry 4 revolution, the smart factory that we wanted to build, and go towards it step by step. And because we are able to successfully pull off this digital twin project, it gave us tremendous confidence that we will be able to take on the next technology. And I want to say thank you so much for hearing me out. I hope the sharing has been fruitful. And I also would like to thank our technology partners for really working very closely with us. So I hope you find your technology partners too, to work closely with them to get where you want to be. Thank you.